The following content has been provided by RWTH Aachen University.
So here's the second example. That's a little more recent, a little more complex, where we built a, this was another crazy project. The World Expo, you know, like the World Exposition that happens every 4 years, the big ones, 4 years or 8 years, I'm not sure, was happening in Shanghai in 2010. And we were invited to design an exhibit there for an extension of the German pavilion that was supposed to capture how you would create the city of the future in Shanghai. And the topic, we chose to model this topic by having people do full body gestures in front of a screen and basically shape trees, houses, and stuff like this with their bodies and create their own neighborhood. That was the message here. You'll see the video here that will show you how the system basically works, and then I'll show you again the finite state machine that steps us through it. Explaining this to the English, to the German-speaking tour guides here. They're currently looking at this instruction screen that tells them what they will do. They will build a city in 4 steps. And it shows them that you will be doing this by posing with your entire body. That's the typical sort of visitor experience when you go there. And they start building houses, and they're now asked all to make gestures. While they do this, we have infrared cameras behind them looking at their shadow in front of this bright light box here, basically. And we take that information to shape a building in the size of their body. So now they've all created buildings, and that's going to be their skyscraper in their little corner of the city they're making. Now they have to connect them up, and they have to all sort of make a long line of people so that there is a way to get power to the building. That was the idea. As they manage to connect their shadows of their hands together, the windows light up. Again, we have a countdown that takes a flash picture, basically a simulated picture, a photo of their interaction, and now we've got electricity. Now they're going to make trees next, again with their body shape. This was a lot of fun, watching people crouch there, make little trees. I much preferred this over all the touch screens you saw at Expo elsewhere. So again, the countdown. They've made trees, and last thing you have to do is water the trees. So you now have to pose to connect the water pipes. If you manage to connect them, then your trees would go green. That's a fail. No particle simulation for the water there. And now you've designed your trees, your houses, and it's all being rendered into similar buildings based on your shapes. And those then get pulled together and turned into a little SimCity city block, basically. And that SimCity block was then rendered into a virtual city that was online. You'd get a little number with your city block and at the exit, and you could basically go online and see your city block. Plus a picture we took of you at the entrance. So that was the experience. It took about 4 minutes to go through. And that's using a variety of computers that are working together and running through various finite state transition networks. So here's the rough technical setup for this. 16 screens with projectors behind them, run by 4 computers. Here's the game server, and we're going to be looking at mostly what the game server is doing and what these game computers are doing, which are all running the same software. There's also, a microsite to render to show the completed city and the photo server and all kinds of other stuff, but not so important. The STN, the State Transition Network we built, starts like this. It's actually fairly simple if you look at it. It basically says the interaction is mostly run automatically on a timer. There's nothing the users can do to change the stepping from one stage to the next. That was important because we had to pipe several hundreds of thousands of visitors through this exhibit over a course of a few months. And so it had to be on a 4-minute clock. After that, it was over. It's like a Disney ride, right? Because we had people piling up at the entrance to our pavilion who wanted to play this game. So any state that you're in will basically, after a timer, move to the next state. The only way to change that is the game master who was standing there, is one person looking after the proceedings that everything was going fine. If they noticed that, I don't know, somebody dropped something or a mom with her kid needed some extra time or something, they could pause the game and hold it and thereby stop the built-in timers. And then once they let go of that, basically continued the game, that was one decision, it makes much more sense to immediately go to the next stage rather than continue the timer, because you've already stopped the clock for as long as the users need it, so you don't need to continue running the timer anymore. Those were the small details that needed to be designed into the system that we could express with this and agree upon. So the initial stage on the server is basically turning on some lights, then asking people to move up to the stage once they entered the room, generate some data. And when the user the controller presses the start game button, that's the only interaction here in normal operations that would be necessary. Everybody's lined up, and he says, OK, let's go. Then comes the welcome screen, timer, posing for the building, turns off some lights, timer runs off, the countdown happens, timer runs off, the posing for the electricity happens. We collect some data that is being passed onto the game computers. The countdown for the electricity, same thing for trees, and same thing for water. And then we show the city, we show the full result of what happened with everybody's stuff, and then we ask people to get the hell out of there so the next group can play. So all of that is happening by timer unless the controller who's standing in the corner is stopping it, the real operator, the only guy who can control the game. The clients, the 4 game computers that were rendering stuff, were basically just sitting there and waiting for messages to go to a different state. So they were completely stateless, if you like. They were completely controlled by the server. So they would start up, look for the server connection, and then sit there, wait for the server to tell them what to do. And the only thing that could happen is, if there was a mistake with signing up as a client. Otherwise, they would simply be sitting there and waiting for messages. And in any state they were in, they would get a state. They would send basically all the data that their player had created on their game state to the server, and then basically wait for the server to tell them to go to the next state. So again, you can see how we were using, in this case, STNs of 2 parts to model what was going on. The cool thing about this is, once you have this STN, it gives you a great way to describe the gameplay or the interaction in sequence. For example, we created this document, the game storyboard, to communicate this stuff to the German government that we were designing this for, and said, look, this is the stuff the user is going to be seeing in front of them on the big screen for each stage. Here's a technical or a textual description of what's going on at that part of the game. Here's what the server is doing technically, and the operator input and the reactions by the system. And here's what the clients are doing and how the light is being controlled and faded and so on. So all these things were in this document in one go, and were able to completely describe the gameplay. You can see from the lining up and the welcome screen to the posing for buildings, to the posing to taking a picture here with a timeout, to posing for trees with another timeout, to the posing for the water. I think electricity was in there as well somewhere, until the whole thing then completes and people see their city block. So it's a long pretty big document, but because we had this STN, we were able to link the user side description that was sort of visually understandable by non-technical people to the technical implementation of what we were doing. So STNs are great. And if STNs don't suffice, if you need to get more complex, you can always make them hierarchical. For example, you can say, hey, I have this sub thing that's going on. I'll put that into an STN. That STN will have, for example, just the menu for graphics, maybe. This could be the menu that we have as in order to draw lines and circles. And in there are entry and exit points, which we then connect to in this larger main thing. So this could be the STN for the entire graphics application, and this could be the submenu for just drawing lines and circles. So we basically don't really increase the expressiveness of STNs. We just make it a little easier to read because we're putting them inside each other. We're boxing them into each other. All right. Like I was saying, we do have a version of that wonderful conducting exhibit upstairs that you guys will be able to try out. Send an email to Phil maybe if you'd like to give a shot, and then we can arrange for that.
This content was provided by RWTH Aachen University.